Hello everyone. It's great to meet everyone here today in person. I hope I will master the green button, but there you go. Okay, so I am data scientist at CB Insights. CB Insight is a technology insight platform. You might have read our public newsletter. It has 800K subscribers. And our CEO signs "I love you" at the end of every one of them. I work for the R&D team that's embedded in the engineering org, and we build end-to-end data science solutions for the company. We ingest 2 million documents monthly at CBI. From data to useful information, it's actually the NLP work that we do at play. The information extracted feed into company profiles, founding trends, market maps, so on and so forth. I actually consider myself really lucky, and my team really lucky, given the explosion of NLP in the past 4 years. So today, I am hoping to share some stories of how we modernized our NLP stack at CBI, our struggles and thrills we had working with transformer models, and finally, also a little bit of musing of where the field is going into and what does that mean for us fellow practitioners. So, let's get started. A little bit about the field NLP. It's a field that cares about enable machines to understand and use human language. And that starts with the problem of representation, right? As you hear me speak, read the text on the slides, information is getting encoded into your brain, which can be retrieved later on. How do we do this for a machine to embed this information in a vector space that can capture the semantic and syntactic meaning and ultimately concepts in human language? From prehistoric time to the Bronze Age, I think we're finally at a point where using large transformer-based language models, we're able to embed amazing amount of information from the human language and also to generalize that understanding for various downstream tasks with relatively few data points. Here is a pretty packed timeline of all the supermodels in the field of NLP. Starting with ELMO, which is LSTM, and that encodes language information as sequential tasks. If we zoom out a little bit, you're going to be seeing a general trend of increasing generalizability. You have BERT starting with single language, expand into XML, multi-language, expand into computer vision and natural language fusion. And we're talking about the DALL-E and the CLIP model over there. And we also see an increasingly amazing performance with zero shot, meaning you don't need to even fine-tune it and it's able to give you an answer already. If we try to zoom in a little bit, let's talk a little bit about BERT. It's already pretty famous out there. But to understand why it's great, I have two analogies for you. Number one is self-supervised training. The analogy I have is, it's as if I taught my 5-year-old to read, right? I all of a sudden unlocked a whole world of knowledge in front of him, which he can learn by himself. With BERT, with the masked language pre-training, we have essentially unlocked the free text out there on the web for the model to learn. And the second important milestone is the attention mechanism. Before that, we're encoding information sequentially, which is number one, slow, and also suffer from long-range dependency issues. But with BERT, we're parallelizing that task. And the analogy would be, when you started reading, you're reading one word at a time aloud, and as you get more expertise, you read faster, right? You gobble up like whole paragraphs and book pages at a time, and that's much more efficient. I forgot to mention the second trend on this timeline, which is increasing efficiency in training and fine-tuning. Let's take a look here, how the model parameter size have evolved. From 340 million, we're now at the trillion level. With Google's GLAM, it's a lot of weights, but we're using sparse activation, so the training time it takes here is actually a little bit faster than GPTM. So that's a increasing efficiency in the model training stage. And that similar thing has happened at inference. So given this context, this is how the NLP stack look at CBI. We actually started building it about 7, 8 years ago. We have data ingestion, things like news, patterns, and then they go through a set of standard processing where you see a couple of like crocodile techniques. Things like stop words, regex, rules, string similarity. They're pretty useful and stable and robust, but they're also prehistoric. Now, if we go into the NLP application layer, that's where we see a lot of interesting stuff happening. We now have 20 plus transformer models running in production at that layer. And we're using libraries like PyTorch Lightning, Allen NLP, pretty fun stuff. This is a visual timeline for how we adopted this new tech or transformer at CBI. 1 month after Google open sourced BERT, we had our first hack day encounter with BERT. We actually went in with very low expectation because we just have 3,000 label data points and what you can do with that with a deep learning model. We walked away impressed, but it actually took us a whole year from that first experiment to releasing our first production model. And it's not a year's time spending in coding something up. It's actually building up that collective knowledge and confidence in this new tech to believe that it's actually production ready. 3 months after that, we released our internal lib that's built on top of PyTorch Lightning and Hugging Face. And from there, we kind of get more comfortable and playful with BERT. We had custom NER problem, we tried zero shot, QA, multilingual. So I think looking back, adopting a new tech is never too easy for an organization. I have 3 small lessons to share. Number 1 is experiment downstream and propagate upstream. The applications in the downstream layers, they typically enable new business capabilities, and therefore it's an easier sell to the organization. Versus the problem on the upstream, things like search or news assignment in my context, they're typically the problem of incremental efficiency. And they also have ripple effect, meaning if you change something here, you're gonna affect a lot of stuff. And that's when you need to actually build up the confidence in the new tech to be able to revamp your tech stack upstream. Number 2 is the importance of investing more time in test harness and performance benchmarks. They sounded boring, especially after you've done with your model. It's always exciting to deploy and forget. But if you don't have good test harness, it's going to become the first blocker when somebody else comes on later on and trying to improve on the same problem with a new tech. The third bullet point is about learning fast and learning slow at the same time. Learning fast here meaning you're not afraid to take something quick and dirty and play with something that you don't completely understand. But at the same time, if a technology is going to stick, you also have to learn slow by collectively investing time in learning about the fundamentals and applying it in heterogeneous contexts. And that's where you get the flexibility when it comes to using the tech. Now, this section is what I call the rabbit hole sections because I spend a lot of time in dealing with these challenges when working with transformers. I should say, though, that transformers, especially the attention mechanism, they deserve a permanent spot in like the NLP temple. Because before that, I would say deep learning is a luxury for most people and team. Because who's going to have millions of data points to train a deep learning model, right? But now we have the paradigm shift from fully supervised learning to pre-train and fine-tune. You can actually walk in with a couple thousand or sometimes a couple hundred data points in your back pocket, and you can train a deep learning model now. That is what we did at CB Insights. At least some problems are. We did a lot of fine-tuning of transformers. This table has a lot of numbers, and it's just for your reference. We used Roberta and XML Roberta, which is multilingual. They're in the hundreds to 550 parameter class when it comes to production inference. I wanted to give you a visual example of how we used it. This is a NLP pipeline at CB Insight for ingesting funding data. We take the raw data, which is news. We do classification across different languages to find out news that are likely that contain deal information for company. We go ahead and extract the company and investor information. Based on that, we're able to do clustering of articles by deal. And we also do entity resolution, linking those names to real entities on our platform. And finally, we do extraction. We're able to provide highlights of the syntax to the human reviewer, which is going to be entering these deals. And we're going to be populating suggested funding information for them as well to speed that whole data ingestion process. And over here, I would say we probably have like 10 or so transformer model running in this entire pipeline. Some of the challenges I'm probably going to be whooshing through, but this one is a top one. Even though the pre-train fine-tune paradigm shift have lowered the threshold for how many training data points you need to have, these relationships still exist, right? The more training data you have, and also the more diverse your training data is, the better the performance. Now, in the problems that I dealt with, some of them like extracting funding information from Turkish, I have under 1,000 data points. But I'm still able to get a above 90% accuracy out of it, thanks to these 3 strategies: hierarchical labeling, translation augmentation, and cross-lingual transfer. All of them comes down to this concept of transfer on top of transfer. When you have labels that have inherent hierarchical structure, you can arrange them to an inverse pyramid and transfer from the widest to the narrowest. When you have training data in different languages, you can try train a multilingual model, such as XMLR in Transformer, and then you can use a dev set for the target language. Amazingly, the model is actually learning something from English, like when it contains funding information, and transfer that learning into Turkish language. There's actually a model capacity versus positive transfer trade-off, but in our case, it worked out really well. Some of the other challenges are label imbalance and long document. For label imbalance, I found upsample and downweighting a really useful technique. The upsample downweighting technique is, at the core of it, you're letting the model see enough examples of each class within each batch. But then you also need to do a reality correction to ingest the real-world distribution into the loss update, and that's the downweighting part. For long document, my amazing colleague Shizi in my team actually did text condensation before feeding it into the model. I know there are models right now that can handle long documents, such as like long former or reformer, but sometimes simple techniques works. You shrink the content, you make the model focused on the part that matters in the article, and you got amazing results in a cheap way. And finally, sometimes you have just highly nuanced class definitions, which call for a rule model hybrid system. And there's no shame in doing that. I'll give an example. Some of the founding rounds that they were tracking, for example, corporate majority versus corporate minority, it's looking very similar, except for the percentage of equity that you're buying from the other company, right? It's very tricky for the model to pick it up, but if you just throw a little bit regex at it, you got the correct answer. So over here on this chart, my apologies, tumor super small, but you kind of get this hierarchy, and the pink parts are where models are at play, and the blue parts are where we have rule system embedded. They work together to achieve the result that we wanted. We've also done a couple of zero-shotting projects at CBI with transformers, with T5 and the BART model. Again, I wanted to give a visual example. This is a pipeline for business relationship. Basically, what we do is we take news articles, we try to see if it contains a business relationship about companies, we extract the players, and then if it's of the vendor-client type, we then go ahead and extract customer references. Who said it? What's the title of the person? And which company he works for? At that last stage, quotes extraction and speaker extraction, we have a T5 QA model at play. And some of the challenges we run into are prompt sensitivity and performance improvement. Prompt sensitivity is when you slightly tweak the question that you ask the model, it gives you a very different answer. For example, in our context, when we ask what company does this person work for versus what place this person is working for, you actually got two different answers. You as a human would never give that to me, right? So we're kind of, in my opinion, beating around the bush now with some of the technique that's called prompt engineering. You either ask 10 different versions of the same question, and then you ensemble the result together. Or sometimes we do prompt augmentation. With performance improvement, the problem is you kind of get stuck with this zero-shot model. It's very powerful, but if it's not giving you what you want, there's nothing you can do. Well, there is something you can do, actually. That is the pre- and post-processing. So like in the previous example, help the model focus, and also once you get the answer out of it, try to clean it up and filter out the noise from there. It's a strategy that we use. Finally, some deployment tips. We at CBI deploy PyTorch inference in a containerized fashion, and if we run into problem of memory accumulation, it got extremely worse when we actually deploy onto big instances with big CPU capacity. You actually see the memory accumulation shooting up like a rocket. We have found out that the problem is actually wrapping PyTorch in multiprocessing. And if you remove that, the problem kind of go away, which gives you the stable memory consumption line over there. While doing the investigation, we also found this alternative memory allocator that is amazing at managing fragmented memory. It comes with pretty stable memory consumption and boosted performance. So if that ever becomes an issue, encourage you to try it out. So now, stepping out of the rabbit holes, I wanted to switch to a little bit of a bird's eye view and talk about where the field is going. If we look back at the history of AI all the way starting from 1950, we see multiple rounds of booms and busts. And finally, with the latest boom in deep learning, we're seeing the field converging in a couple of general directions: generalizability, explainability, efficiency. And that's the first frontier, right, where the research is happening. There's also the second frontier with widening industrial applications. We now have a teeming ecosystem. Many of them are actually here today with AutoML, data curation, supermodel as a service. When it comes to ML practitioners, we're seeing increasing functional specialization. That's happening. I think for the first time in the AI history, we're actually seeing an early sign of from niche to mass market adoption. This is just a market map from CB Insights that try to chart out the 90 top founded AI SaaS and AI-powered startups within each domain. So with this transformation happening, how do we comprehend it and prepare for it as ML practitioners? It's interesting, I got an amazing, striking analogy from the field of art. I was roaming the MoMA bookstore one weekend, and I found this little book that talks about Bauhaus. Bauhaus is a German art school that's founded in 1990, and it's the starting point of design, which is now in every aspect of our life. Part of its prospectus reads, "Our task is to make a new kind of artist, a creator capable of understanding every kind of need, not because he's a prodigy, but because he knows how to approach human needs according to a precise method. We wish to make him conscious of his creative power, not scared of new facts, and independent of formulas in his own work." If you swap out the tactical means in art with that of data science, you got Bauhaus for data science. I think there is a lot of parallel that's between design and the current phase of data science. Like design, part of data science is very tightly coupled with the specificity of the domain. And also, with rapidly evolving technology, we're actually constantly adopting new tools, reinventing old tools, and updating our belief of what constitutes the best solution for a particular problem. On the second frontier, I think our mission is to learn and develop profound new business capabilities with data science method. And that often means having to learn and deliver amid high uncertainty. And it requires all of us to be a 3-in-1. A fox with range, a hedgehog with depth, and finally, effective collaborators. To expand on that topic, I highly recommend David Epstein's book called Range. But just to put that into the end-to-end data science workflow and illustrate it a little bit more. As data scientists, we're trying to marry business capabilities with data science method. And in this chart, I have kind of bulleted out where I currently spend my time doing data science. There are opportunities to become a fox when it comes to exploring the problems and the solution space, when it comes to testing parallel hypotheses, be flexible with your method, things like that. And there's opportunity to become a hedgehog when you're actually learning about the fundamental of a new tech. There are other areas where I believe I can use a lot of help from AutoMI, or maybe MLOps or MLDev. Areas I wanted to cut down the time spent are like testing, deployment, monitoring, scaling. There are also areas where I think we should spend more time because they're more coupled with the domain. Things like data curation, test harness, diagnose the experiment that you've run and planning next steps. When it comes to being an effective collaborator, I think what it means is engage in healthy debate and cross-pollination. And ultimately, it's about turning this flywheel of learn, experiment, assess, and deliver as fast as you can. There's actually one point I forgot to mention, supposed to belong to 3 slides from here. I'll just say it now. I think before the omnipotent AGI, artificial general intelligence comes and gobble us all, I think the increasing automation in the ecosystem is going to actually boost innovation and productive teams for all the ML teams and data science teams, but especially for smaller size teams, which should embed themselves in every type of organization. And that's all I wanted to say. Questions?
I think we have time for maybe 1 or 2.
Thank you for your presentation. Actually, I have a question. So on the performance of your models, especially for the zero prompt, like question answering models. So besides the typically defined metrics, how you evaluate your success to serve your clients?
Oh, I think there's always 2 sets of metrics, right? One where we have control over is the technical metrics, whenever it could be F1 or accuracy. The other set of metrics is product metrics. How do you define product success? And for the CBI Insights platform, it's about how salient that feature is, how many users actually use it, how deeply they engage with that feature on the platform. And we can measure it by, if you have robust event logging on the front end, you can actually see how much time a user spent on a particular section on the profile, and that kind of gives you a sense of how success or sticky this feature is.
Thank you. I think we have time for 1 more question, and here it is.
Hi, yeah. When I was in high school a long time ago, on the front of in the front of the computer room, where they were, had a PDP-8E in the back, talking about the 70s here. They had the teacher had a sign. It said, "The hard thing about AI is explaining to the computer that when Mary had a little lamb, she didn't have it for lunch." So I feel like, we're kind of still at that stage in natural language processing, that we're doing all this processing based on the structure of the language itself, but without any context. And I was wondering what your views are on processing and adding context.
That's a great question, and I happen to have a great answer for it too. It happens that this is a challenge that we have partially solved, and it is actually a huge breakthrough in NLP, is our embedding of language have gone from not context aware, meaning each embedding will there will be a single embedding for every word. A bank as a financial institution would be the same as the bank of a river. That's happening in the prehistoric time. With bag-off words, even with word-to-vec, that is the case. In the Bronze Age, we have actually gone into context-aware embedding, where you would be able to understand Mary has a little lamb is not lunch. And we're able to do that because we're training in the model in such a way that its distributed representation is also taking in meanings from its context. So the embedding of the word is actually reflecting the context as well.
Thank you very much.